Okay, so assume a poll of 20 BAF students, Bachelor of Accounting and Finance, is taken in an economic national research study. The purpose is to determine X number who prefer working in the banking industry. Suppose that 60% of all the BAF students prefer working in the banking industry. Find there. All right. So here a study has been conducted. All right. And we're trying to find out of our participants, those who prefer working in the banking industry. Okay. So in this case here, we've got two outcomes. It's either you prefer working in the banking industry or you don't prefer working in the banking industry. Those are the only two outcomes. So this means we're dealing with a binomial distribution. Okay. Binomial distribution is a test where there are only two outcomes. Okay. Yes. So we have to get our data straight. P, which is the probability of a success. Because remember, there are only two outcomes. These outcomes represent either a success or a fail. So in this case, we're trying to find out students who prefer working in the banking industry. Okay. So a success, which is denoted as P, is students who prefer working in the banking sector. Okay. So the probability, okay, of getting a student who prefers working in the banking sector is 60%. So the probability of a success in this study is 60%. Okay. Then in this case, a failure, which is Q, represents the students who don't prefer working in the banking sector. Okay, so we need to know this probability. Remember, the probability of a success and a failure, probability of a success P plus probability of a failure equals 1. Okay, so to find the probability of a failure, that's why I've seen this Q equals 1 minus P. Okay, so 1 minus 0.6 represents 0.4. Okay, so the probability that when you do this test, that you find students who don't prefer working in the banking industry is going to be 40%. Okay, 40% don't prefer working in the banking industry. That's the probability. And 60% prefer working in the banking industry. Okay, so we've got our data P, which is the probability of a success, Q, which is the probability of a failure, students who don't prefer working in the banking industry. Then N represents the sample size. How many people were taken in this study? Okay, they told us a poll of 20 students. Okay, so here that lets us find the mean and the standard deviation of X. Okay, so one find out the average number of students who prefer working in the banking industry. That is the mean. So the formula for the mean, it's here. EX just represents the expected value. Okay, it is the sample size N multiplied by the probability of a success. Okay, so there are 20 students and 60% prefer working in the banking industry. So 20 times 0.6, you get 12. So what this 12 is telling us is that on average, there are 12 students who prefer working in the banking industry. Okay, on average, that's the average number of students who prefer working in the banking industry. Any questions before I go to the next part? We have to calculate the standard deviation. Next is the standard deviation. Yeah, and sample size multiplied by the probability of a success. The success in this case is students who prefer working in the banking industry. Q, probability of a failure. In this case, students who don't prefer working in the banking industry. Okay, you're getting the square root of this. So you're going to say 20 times zero point 0.6 times zero point 0.4. You're going to get 4.8. All right. The square root of 4.8 is basically is 2.2. So what this standard deviation is telling us, okay, it's telling us that if we conduct this test, okay, here we've been told on average 12 people prefer working in the banking industry. And we'll be told the standard deviation is 2.1. Standard deviation just says how far the data is from the mean. Okay, how far the data is from the mean. In this case, is how many students you're going to find out who prefer working in the banking industry. The average number each time you conduct this test. Where what range of values do you expect to find that in? Okay, so standard deviation of 2, you're going to say 12 minus 2 here, that is 10, and then here 12 plus 2, that is 12. So basically, what this is saying, as colleagues, is next time you conduct this test, you might find the average number of students who prefer working in the banking industry. Well, this is 14 here. This is the range where you might find the average. Next time you conduct this test, you might find 11 students prefer working in the banking industry. The other time you conduct this test, you might find 13 students on average prefer working in the banking industry. The next time you conduct this test, you find maybe it's now 14 students. Okay, so the more times you conduct this test, you're going to see that the average is going to be near 12. Okay, it's going to be in this range from 10 to 14, but near the average figure, which is 12. Any questions? That's what standard deviation is telling you. Okay, part B. The probability that at least a quarter of students favor working in the banking industry. So I want to find out what is the probability that at least a quarter of the students prefer working in the banking industry. So a quarter of 20 students is 5 students. Okay. So I want to find the probability that at least 5 students prefer working in the banking industry. Okay, so you're going to write it like this. The probability that at least 5 students prefer working in the banking industry. Okay, this is the probability that we want to find. Now, this is where you need to pay close attention. In order to find the probability of at least 5 students preferring to working in the banking industry, you need the probability. You start with 5, the probability that 5 students prefer working in the banking industry. Plus, you also need to find the probability that 6 students prefer working in the banking industry. Plus, you need to find the probability that 7 students prefer working in the banking industry, plus the probability that 8 students prefer working in the banking industry, until you reach the probability of 20. Okay, you need to find all these probabilities until you reach the probability of 20. Okay, until you reach the probability that 20 students prefer working in the banking industry. Now, colleagues, that is a lot of time. Okay, that would be a lot of time. Find the probability, all these probabilities from 5 up to 20. That is going to be a lot of time. Okay, so this is the shortcut that you can do. Okay, so that you avoid doing all of that work there. All right, you're going to say, okay, the probability, because remember, probabilities always add up to 1, right? Probabilities always add up to 1. So I'm going to say the probability that at least 5 students prefer working in the banking industry plus the probability that less than 5 students prefer working in the banking industry equals 1. Okay. Remember, since here it's like we'll put this as a number line. Okay. Here, from 5 to this side, from 5 up to 20, is representing the probability that at least 5 students prefer working in the banking industry. Okay. So now from 0 to 4, okay, from 0 students to 4 students, this represents the probability that less than 5 students prefer working in the banking industry. Okay. So we're just combining these two regions, this region and this region. When you add up these two probabilities, you're going to get 1. Because you want to avoid this long process here. It will take, by the time you are finished with the question, the exam is over. Okay. So in order to get the probability that at least 5 students prefer working in the banking industry, you're going to say it's going to be 1 minus the probability, excuse me, that less than 5 students prefer working in the banking industry. This is how we're going to find this. Okay. Yes. So now, in order to get this probability here, that less than 5 students prefer working in the banking industry, so the probability that less than 5 students prefer working in the banking industry is going to be the probability that 0 students prefer working in the banking industry. Let me just get bundles colleagues. Then I resume the system. Okay, colleagues, just hold on. Sorry about that. I was kicked out. Okay. Remember, colleagues, we're trying to find the probability that at least five students prefer working in the banking industry. Okay. So one way you can do it to find the probability that at least, meaning the minimum number of students who prefer working in the banking industry have to be five. It means you have to get the probability that five students prefer working in the banking industry, six students prefer working in the banking industry, seven students, until you reach 20 students. Now, this will be a very long process. So, to avoid this long process, you just say, okay, since they ask for the probability that at least five students prefer working in the banking industry, so it means the other probability will be the probability that less than five students prefer working in the banking industry. Okay, because less than five is from 0 to 4. Okay, then at least five is from 5 to 20, since there are 20 students. Okay, so we have the probability of these ranges basically. So the probability of these ranges, when you add them, it equals to 1. Okay, so that's why I said probability that at least five students prefer working in the banking industry plus the probability that less than five students. Don't say more than five because we have already accounted for five and above. That's why I've used less. Five has already been accounted for. Five up to 20 has been accounted for. So you need to account for 0 to 4 equals 1. Then we just took this over the equal sign. Okay. So now what we're focusing on is getting the probability that less than five students prefer working in the banking industry. Okay, so this includes the probability that 0 students prefer working in the banking industry plus the probability 1 student prefers working in the banking industry plus the probability that 2 students prefer working in the banking industry plus the probability that 3 students prefer working in the banking industry plus the probability that 4 students prefer working in the banking industry. Okay. Once you get all these probabilities and add them up, it will give you the probability that less than five students prefer working in the banking industry. Okay. So this is where now you need to calculate each of these individual probabilities using the binomial distribution formula. Okay. Yes. So you're going to start with this one here. The probability that 0 students prefer working in the banking industry. All right. So it is here. Remember, the sample size is 20 students. The number of students we are looking for here is 0 students. So x equals 0. Okay, so here, let me walk you through these calculations here. Remember the formula for binomial distribution: n factorial over n minus x factorial x factorial multiplied by the probability of a success raised to the power x multiplied by the probability of a failure raised to the power n minus x. This is the formula we're going to use to calculate all of these probabilities. What is just going to be changing is the x values. N will remain the same, P the same, Q the same. But what's just going to be changing is these values of x. Okay. So here n is 20. Where there is n, you just put 20. So you're going to say 20 factorial. N minus x, n is 20, x is 0. So you say 20 minus 0 factorial. Then x is 0, so you're going to say 0 factorial multiplied by the probability of a success, 0.6, multiplied by the probability of a failure, 0.4, raised to the power 20 minus x, that is 0. Okay. 20 minus 0 here. Okay. So once you do your tabulations, so I'm just going to do for x equals 0 because this is a long process. Once I'm done with the video, we are going to, I'm going to make sure that you know how to put these values in. Okay. But this is a very long process. So I'm just showing you, I'll use this one, probability that x equals 0, right? Then it will be the same formula we use for all these other values. So you're going to have 20 factorial here over 20 factorial. 0 factorial equals 1. Okay. 0 factorial equals 1. 20 factorial just means you're multiplying 20 by all the numbers below it. Okay. 20 times 19 times 18 times 16 times 17. You just go until you reach 1. Okay. But in this case here, the factorials can cancel each other out. 20 factorial, that gives us 1. Okay. 0.6 to the power 0 is also equal to 1. Okay. This one here, 0.6 to the power 0, that is also equal to 1. Then 0.4, this 20 minus 0 gives us 0.4 to the power 20. 0.4 to the power 20 is this. It's this figure here. So once you multiply 1 times this figure here, you get 0.0.00000000111. This is the probability that no student prefers working in the banking industry. Okay, these values are just giving us the probabilities of how many students prefer working in the banking industry. Okay. The probability that 0 students prefer working in the banking industry. Okay, very low probability. So the process will continue because you have to find out the probability that 1 student prefers working in the banking industry. Okay, so you're going to use this formula again. N is 20, x is going to be 1. So let me just do this last one here. You're going to have 20 factorial over 20 minus 1 factorial. This n minus x. 20 minus 1 factorial multiplied by 1 factorial. Multiplied by p 0.6 to the power x. X is 1. So it's a 0.6 to the power 1. Multiplied by q 0.4 to the power n minus x. So to the power 20 is n minus x is 1. X equals 1. Okay. So this This first part here, you're going to say 20 factorial over 20 minus 1, that is 19. 19 factorial multiplied by 1 factorial is 1. Okay, so you just multiply it by 1. This 1 factorial equals 1. Okay, multiplied by 0.6 to the power 1 is 0.6. Multiplied by 0.4 to the power 19. Okay. So that day, if you don't have a calculator, you can just do it like this. You say 20 factorial. Remember, it's the numbers counting down from 20. So it's going to be 20 multiplied by, this is one shortcut you can use. You end on 19 factorial. 20 times 19 factorial. Why? Because I've got a 19 factorial down here, so I know I can cancel them cancel them out. Okay, this one is insignificant. Okay. Or we can still put multiplied by 1 here. Okay, these 19 factorials will cancel each other out. Okay, that's how I've remained with a 20 here. The 19 factorials cancel each other out. Okay, 0.6 to the power 1 is this. 0.4 to the power 19 is this. When you multiply this, this is the probability that one student prefers working in the banking industry. Okay, colleagues, this 0.00000033, the probability that one student prefers working in the banking industry. Okay, so colleagues, the process will go on until you get the probability that 4 students prefer working in the banking industry. All right. Once you've got these probabilities, you need to add them up. This plus this probability plus this probability plus this probability plus this probability here. Okay, all these probabilities, you need to add them up. Okay, and when you add them up, it's giving you the probability that less than 5 students prefer working in the banking industry. Okay, so you add up all these probabilities here. Okay, and once you do your tabulations, you get 0.0032. You're subtracting all of that minus 1. 1 minus 0.0032, it is 0.999. So this is the probability that at least 5 students prefer working in the banking industry. Probability that at least 5 students prefer working in the banking industry.